Excellent. Okay. Algebra 2. Algebra 2. Okay. Law of sines, law of cosines. Here we go. All right, so this should already be done. And I don't think I've got the ed puzzles done, but I got the tests, the practice test, and the Delta Math already put in the grade book earlier today. So if you didn't get it done, I guess you can do a retest if you don't like your grade. So retests are still available, but all grades have been put in from Delta Math earlier today. With that, let's talk about laws of sines, laws of cosines. Everybody should be familiar with this at this point because everybody should have done their ed puzzle. Let's see how well it goes. All right, you have a three-parter. Does anybody remember what I put in this three-part? By the way, close your Chromebooks. All the way, thanks. All right, cool. Now, let's do it. Let's do it. What goes up here? This, by the way, I'll give you a hint, is the law of sines. So what do you think may go in here? Yo, Marlon. A, I agree with you 100%. In fact, there's an A here and a little a right there. What else goes in this fraction? Probably a sine. So let's go sine of big A over little a. Then what? Anybody have something else? I'm going to go with B's. I like that. It's B's. Sine of big B over little b. And then finally, you guys got it. Nothing escapes you guys. All right. So we got this. Now, this law of sines, law of cosines applies when I don't have a right triangle. So something like this guy, where I have, I don't know, how big is that angle? Somebody. 30. Sure. Now, just because that 30 doesn't make the other one 60 or 90, right? Because we're not allowed to have a 90 in here. How big is this side over here? What is it? 40. Okay, sure. And so how big is this side? Probably ought to go with like maybe 45. What do you think? All right. So here we go. A, B, C. Now, what do I label this side over here that's across from angle C? Probably ought to label it little side C. Does that work? Because C goes with C. Well, big A, that makes this one little a. There's big B, so this must be lowercase b. Is everybody okay with that? All this is labeling a triangle. And we need to find some missing pieces. Well, here's the deal. Law of sines simply means I need to find a pair that I know. Which angle, A, B, or C, do I know both the angle and the side that go with it? A. So if I said sine of A over A, so I'm going to say sine of 30 over the side 40. Does everybody agree with that? I got this pair right here. Now, I need to make another pair. Well, I don't have any more total pairs. What's the other thing I do know?
B.
I do know a little b here. That's 45 angle. What don't I know? Angle b. So can I say sine b over 45? How many variables are left in this problem? Just one. How do I solve if something is a fraction equals a fraction? Cross multiply. Could I say sine of 30 times 45 equals 40 times sine of b? There we go. What do I need to do? Can I put this into a calculator? Can I put 45 sine 30 into a calculator?
What does that say again?
Says sine of 30 over 40 equals sine b over 45. So this is, so I cross multiply, 45 sine 30, right? Because those two go together, equals 40 times the sine b. Now, I need somebody to give me a number for this guy right here. What is 45 times the sine of 30? 22.5 equals 40 times sine of b. How do I get b by itself? Divide by? Ooh, I can't divide by b. It's all the way stuck in a. Divide by 40. I agree with that. So what's 22.5 divided by 40? Should be 0.5 something?
0.5625.
Okay, now why am I going 4 places? Oh, well, that would also make sense. What if it went on forever and ever and ever? Why would I go 4 places? Then I have enough to round this. Very good. So I have 0.5625 equals sine b. How do I get rid of the sine? Sine inverse. How do we always get rid of the sine? Sine inverse. So here we go. If I say sine inverse of sine inverse of 0.5625, that should equal b. What does b equal?
34.228.
Okay, and if I were to round it to the nearest degree, what would it be? 34 degrees. Okay, now let's think about this a little bit. If 30 degrees went with a side of 40 feet, wouldn't it make sense that a side of 45 feet, which is a little bit longer, would go with an angle that's just a little bit bigger? Wouldn't that make sense? Okay. How do I find angle C? Miss Hale, how do I find angle C? Well, here's the question. Do I already know 2 of 3 angles in a triangle? So what might I be able to do? How many degrees are in a triangle all together? There's 3 angles all together. How many degrees?
Oh, 180.
180. So what could I do to get this angle over here? Subtract those fellers from 180. Wouldn't that make sense? 180 minus 64, 116. Okay. Now do I know this angle? So if I know that angle, what can I now do? Find the side of C. So I want you to set it up. So here we go. We need another set of setup.
So this time, do we put all 3 of them?
No, you would still just choose 2. Now, which one would you choose to start with? You could totally do the B, couldn't you? But did I round that 34 just a little bit?
Yeah.
So which one would be the best one to start with?
30.
Yeah, let's go sine of 30 over 40, just like last time. Do you agree? And now we say sine of what? 116 over C. Go, find it. Cross multiply. Find it. You may need a pencil. Maybe you need a piece of paper. Maybe you need a calculator or that phone. Sine of 30 is 1/2 of C equals 40 times sine 116. Somebody give me a number for that guy. What is 40 times sine 116?
35.9517.
35.917.
9517.
9517, okay, equals 1/2 times C. Now, where did 1/2 come from, by the way? So what's the sine of 30? Opposite, I thought it was 1/2. So what do I do to get rid of a half? Multiply by, what's the reverse of 1/2? Can I divide by 1/2? Yeah, I could divide by 0.5 if I wanted. What's 35.9 whatever divided by 0.5?
71.9.
71.9, which is about how big?
72.
72, yeah. All right. Now let's see if this makes sense. 30 went with 40, 34 went with 45, 116 went with 72. Does that make sense that it's going to be a lot bigger? Yeah, great. Here's the deal. All I had to do was find a pair and use it to find the other two pairs. That's what we had to do. All right, do the next one. If I have something like this, how big is this angle? 20, sure. How big is that one? 50, love it. Okay, and this side here is 6. I don't want to go 6. This is just 6. All right, A, B, C. All right, find little a. Go. Find little a. Boston, what pair do I know right now? I need an angle and a side that are paired up. What pair do I know? I know C. Right here, I got this angle and I got that side, right? So what's my first part of fraction? Sine of over, which is 6. You agree? So can I use that little chunk right there to solve everything else? Yeah. What do you know now? What goes on the other side? A, because I know the angle, right? So I say sine of 20 over little a. What am I going to do now, guys? All right, let's do it. Let's cross multiply. Somebody have me an answer yet? Okay. 80. Help me out here. What is sine of 50? Oh, okay. Sine of 50. Perfect. Equals. Now, what's sine of 20 times 6? Okay, sine of 20 times 6? Or 6 times sine of 20? 2.052. That sounds about right. Okay, so then how do I get A by itself? All I got to do is do what? Divide by 0.7660, right? Okay, and what is 2.052? 2.052 divide by 0.766. 2.052 divided by 0.766.
2.678.
Okay. Did everybody else kind of get something in this ballpark, even if it's not like per exact, because maybe you rounded a little differently than he did? But can we all agree that it's about 2.7? Is that cool? Now let's see if it makes sense. If 50 went with 6, would 20 go with about 2.7? Makes sense. Okay, cool. How do I find the rest of it, Gosser? What's the next thing I need to find? B. How in the world do you find B? Do you already know 20 and 50? So what's this? Well, whatever 180 minus, yeah, so it's 110. Does everybody agree? So then can I use that to find little b? Let's do it. Go for it, guys. Now, Sierra, you weren't here. What we're doing here, the basic process is from what you're given, stuff you're doing, find a pair you can find. So I have this angle and that side. They go together. Does that make sense? So it's sine of 50 goes with 6. Well, Gossard just told me 110, so I'm going to say sine of 110. What does it go with? Little b. So now all I have to do is what? Cross multiply. That's it. That's it. What is sine of 50, people? Sine of 50. Hello.
0.766.
Perfect. Over 6 equals, what's sine of 110? Ooh, no.
0.9396.
Point what?
9396.
Okay. Just sine of 110. Just like, now, not the cross multiply yet. Now, if you did cross multiply, what'd you get, Aiden? 5.63 equals 0.766 times b. I agree with you there. Does that make sense? By the way, here's how I knew that Aiden was giving me this other number. All signs are going to be somewhere between -1 and +1. So they're going to be a decimal. Now, at this point, what's the only thing I need to do, guys? Divide everything by?
766.
Okay.
So what I did is that wrong?
No, you were a step ahead of me. I just asked for just that. You gave me that times that, which is fine. So that's correct. Does that make sense? So what is 5.63 divided by 0.776, guys? 7.4. Do we agree with that? Okay, does it also make sense that a big fatty 110 degrees would also go with 7.4 in our case? Okay. Have we been doing ratios when we did 45, 45, 90s and 30, 60, 90 triangles? We did that. This is just ratios that have signs in them. That's it. All you had to do here was find a pair. This pair goes with this pair. This pair goes with this pair. That's all you had to do. All right. Okay, what do you want to do? You can't? She says I can't do the law of sines. Here's the thing, it is a trick question, isn't it? What is in this problem? A 90. So does she have to do the law of sines? No, but could she do the law of sines? She could. Could she say sine of 20? What does 20 go with? 6. Over, can I say sine of A over 14? Could we do that right there? Does that hurt anybody's feelings? Find the pair, find the opposite side. Go ahead and find all that. Tell me what A is. Now, by the way, when you're done, what would you expect A to be? Something around what? 70 maybe? That may be a little big, but maybe. Oh, actually, no, never mind. It should be around 70, shouldn't it? All right. Mode. Degrees. Okay, so I'm going to take 14 times sine 20 and I'm going to divide it by 6. How many people got 0.7980 blah, 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 blah? Cool.
Wait, so you did the sine 20 times.
I did these two times each other and then divided by 6. Because if I cross multiply, that's what I end up with, right?
What happened to the sine A?
Well, that's the whole point. At this point, I got this number. What does that equal? Sine of A. What's the last thing I need to do to get the actual answer? I got to do sine inverse to get rid of that. The reason I stopped at that point is because that is a very common problem. Kids will come up to me and say, "Oh, I totally did it right, and it's marking it wrong." Well, what did you get? I got 0.79 whatever. Okay, cool. Except for the fact that you actually have to take the inverse sine of point. Yeah, my screen thing. What is the inverse sine of 0.7980?
52.9395.
That doesn't make sense. Double check. Somebody else do the inverse sine of 0.7980.
52.
Okay, then I screwed up. Somebody take sine of 20. What's sine of 20?
0.3420.
0.3420.
Yeah.
Oh, stupid. Okay, pause. Here's the problem. I put a 90 and a 20 here, right? Where did I pull the 6 and the 14? Clean out of my ear, right? I made them up. I didn't make up a side that fit with a 90 because I'm dumb. Okay, I should have made up a side that makes a 90. That's fine. In this case, if that was not a 90, this would be 52 point whatever, correct? Great, and then could I find this missing angle? And then could I find the missing side? Yes, I could. All of those things could happen. What would be a lot better is if you had a 90, a 6, and a 14, what should you do to find this angle here, or this angle up here, or that side over there? What would you do to find the third side of a right triangle? Pythagorean theorem. Could you say 6 squared plus 14 squared equals c squared? If I wanted to find this angle, what side is this guy over here? Opposite. What is this side over here? Adjacent. And so what would I use if I have an opposite and adjacent? Tangent. I'd say, oh, tan of thing I don't know equals 14 over 6, and could I go from there? Yes. Now, that's law of sines. That's using sine, cosine, tangent. Let's talk about a different type of problem. 11, 35, and 7. 11, 35, and 7. How come I'm not going to use law of sines here? How come I cannot use law of sines? I don't have what?
Opposite.
I didn't have a pair, did I? I don't have anything opposite each other. Because over here, this is A, that's little a, I got angle A, but I don't have side A. I got, side B, but I don't have angle B, do I? Same thing for C and C. I don't have it. I can't use law of sines. This is where I have to use law of cosines. Law of cosines. Law of cosines would be a squared equals b squared plus c squared minus 2bc cosine A. Got to memorize that. What's up? Yep. One that should have been washed by this morning. So this is one option. By the way, you have two other options. B squared equals a squared plus c squared minus 2ac cosine of b. It could have been c squared equals a squared plus b squared minus 2ab cosine of c. What is the only thing that must be true in any version of the law of cosines? We did talk about this in the end puzzle. What has to be true about any version of the law of cosines? Whatever's up front has to be at the end. Which one of these versions should I use on this triangle? Well, which one do I know? Which angle do I know? A. So can I plug all this information over there into this law of cosines right here? Let's do it. I don't know little a, but what's little b? 11 squared. What's c? Squared. Minus 2 times 11 times 7. Cosine of what angle do I know? There it is. How many variables are left in this problem? How many variables are left in this problem? Just the front. Okay, here we go. Aiden Huddleston. What is 11 squared? Perfect. Fowler, what's 7 squared?
Dude, I'm still writing down my equation.
What?
I'm still writing down the problem. I didn't write that.
All right. What's 7 squared? What's 7 times 7?
Or no.
Close. 7 times 7.
I said 49.
49.
Yeah.
Okay. Lorish, what's 2 times 11? Good. 22 times 7, though. Do you have a calculator?
Yeah.
22 times 7?
154.
154 times cosine of 35. Okay, Gossard, what do you want to do next? I think that's a tremendous idea. So that's going to be what, 170, am I correct? Okay, now, Bannon, tell me what you're not going to do, because it's the biggest mistake that all kids make. They want to really do this, but it's the wrong thing to do. What's the wrong thing to do? What does it look like you might want to do here? You might want to subtract those two, correct? How come she cannot subtract 154 and 170?
Because the 154 is attached to the cosine.
Yeah, is that attached to cosine? So what should I do first, folks? Yeah, cosine 35. Somebody find me that number right there. Yes, sir? 120. 126.14. Do we agree or disagree with him? You agree? Okay. Now can I subtract from Sierra? Okay, so let's go ahead and do that. What do I come up with? 43.86. Okay, now Owen. This is the second biggest mistake kids make here. You ready? They say, I got 43.86 and it says it's wrong. I did everything right. How come it says it's wrong? Tell me why 43.86 is wrong. I want you to look right in here. You can't have a squared. What do you need to do? How do you get rid of squared? Square root. Okay, so can we take the square root of both sides, guys? Boston, do you know what the square root of 43.86 is? You have a calculator, right? Fowler, you had a question over here. Boston. Oh, okay. Gotcha. What did you get, bud? Turn it sideways. There should be a square root button.
I think it like says.
Say here, square root. So type in 43.86 and hit the square root button. Woo. All right. Okay, 6.622. Is that what we got, everybody?
Yeah.
Okay. So would 6.622 make sense in this situation, Hunt? Or at least be in the ballpark, maybe? She said, probably. Because why? Got 7, got 11, like 6 point. Okay, that's in the ballpark. Now, here's my question, guys. How do I find angle B or angle C? How do I find angle B or angle C? Okay, you're working too hard, guys. Do I now have a pair? Do I have a pair right there? An angle and a side? If I have an angle and a side, what can I use? Law of sines. Can I say sine of 35 over 6.622 equals, which angle do you want to find? Blandingham, which angle, B or C? C, so it says sine of C. So she's looking at C. What angle or what number goes under the sine C? C goes with which one? 7. Great. Now can I cross multiply and solve it? Cool, let's do it. So we cross multiply 6.622 sine of C equals 7 times sine of 35. And I put it all in my calculator. And what do we come up with, guys?
4.015.
4.015. That, oh, here, just this part?
Yeah, sorry.
Okay, 4.015 equals 6.622 sine of C. What do I need to do with that 6.22? Divide. So sine of C equals, and it's going to be somewhere around 0.6 or something, right? What is 4.015 divided by 6.622?
0.606.
606. All right, 0.606. Is that my answer? Is 0.606 my answer? No, what do I got to do? Sine inverse. I heard it. I heard it. Sine inverse, and what angle does that give you? Yes, it's good, but what is it though?
37.322.
37.322. How do you find the missing angle? I got 3 ways technically I could do it. What's one way? What's the easiest way to find the third angle? Subtract from 180. Would that do it? Yeah. What's the second way I could do it? Well, I got sine of this to that. Could I do law of sines using those two. Or if I wanted to, I could do law of cosines again. 3 different ways. In the last one, we had to use law of cosines because I didn't have any pairs. In this case, what's my problem? I don't have any angles. So can I use law of sines? Can't use law of sines because how come? No pairs, no angles. I have to use law of cosines. I need somebody to tell me which angle we're finding. I don't care which one. Pick one. Addie, which one, A, B, or C? A, she says. Okay, what did we say had to be true about the law of cosines? If I'm finding A, the angle, where do I start? I need A squared. A squared equals B squared plus C squared minus 2. BC cosine A, because if she has A on one end, she has to have A on the other. So here we go. Let's start it up. What's the side A? Nope, side across from A. 11 squared equals, then what? 19 squared plus 12 squared minus 2 times 19 times 12 times cosine of thing I don't know. Thing I don't know. Do you agree? So here we go, just in case for those of you that were still catching up. If we want to find angle A, what side did I start with? A, 11 squared. Then I put the other two, 19, 12, 19, 12, cosine of A. Is everybody good there? Start simplifying, go. Start simplifying. What's 11 squared, Daytona? Nope, that's squared. 11 times 11 is? You have a calculator, right? Why are you putting it away? 11 times 11 is? 121. Now, I have no idea what 19 times 19 is, anybody? What's that? What is that?
361.
361, they say, plus 144. Does everybody agree with that? What's 2 times 19 times 12? 456. Yeah, it is, because we got the minus sign out in front of it. Does that make sense? Yep, that works. So is everybody good to this point? What do I do next?
361.
Love it. Okay, which is what? 505? Okay, real quick. What is everybody really tempted to do that would be 100% wrong? Yeah, what do I not want to do right now? Do not subtract. How come? Because it's attached. What do I want to do?
Would you subtract 505?
I would. Can I move that 505 over here? What is 121 minus 505?
Negative 384.
Perfect. Equals negative 456. Cosine A. Now what do I do?
Divide by negative 456.
Yep. Okay, so what decimal equals cosine of A? Like 0.6 or 7? What is it?
0.8421.
Do we agree with her that's 0.8021?
84.
8, what is it? 8421. Good. How come 0.8421 is not my answer? Inverse cosine. A equals
32.63.
32.63. Do we agree with her, yes or no? So I'm gonna call it 33. Okay. Tell me how to find everything else. How do I find everything else? I think you're right. I could do the law of cosines again, couldn't I? But that's a lot. So is it easier just to say, oh, wait a minute. Do I know that angle on that side right there? So I could say, oh, sine of 33 over 11 goes with sine of B over 19. And can I solve it pretty fast? Okay. Could I do it using law of cosines yet? Yes.
Use the C2.
Yeah, you could have totally, yeah, you could have, the next thing you're gonna do, you're gonna say sine of 33 over 11 equals sine of C over 12. Right? That's the other part you're missing. So there you go. Why in geometry do we need to know the law of sines and the law of cosines? Because otherwise in geometry, we're stuck using only right triangles. And to be fair, there's a whole lot of triangles in life that are not right triangles. Okay. Okay, so for today, you are to have watched the Ed puzzle, drawn the pictures as best you can. For Thursday, do Thursday. For you guys, it will be due Friday, because the next time I see you is Friday, correct? Okay, next time I see you is Friday. So we're going to go here to the notes. You have 6 problems to do. How do you attack this problem right here? What's the first thing you do to attack this problem? Can I find this missing angle right here by subtraction? Cool. How do you find anything else? Once I know that this is 74, if this is 74, can I do law of sines? Sine 74 and 6, and then go sine 24 and z. Could I do that? Okay, how am I going to do number 2? Am I going to do number 2? I can find this angle, that's easy, but I don't have to start with. What could I start with right now? Could I do 105 and 12? Would those two go together? And then could I find the missing side? Okay. For number 5, how come, what would I do for number 5 to find Z? Boston, and number 5 right here, how would I find Z? That's it. How come he can use Pythagorean theorem here, but he couldn't use Pythagorean theorem on the last 2? What? Yeah, there's a 90 in it. Number 3, what do we got for number 3? By the way, this is a Z right here. Gonna have to use law of cosines. How come I have to do law of cosines? There's no pair, there's no angle, is there? So is it just like the one we just did? What about number 4? What about number 4? Can you use law of sines? Nope, so it's going to be law of cosines. And number six, what are we gonna do? Number 6. Law of cosines is possible, but man, would that be a pain in the wazoo. It's probably gonna be law of sines. How come law of sines would be a good one here? You got the 40 and the 8. I agree with you. So those 6 problems are due Friday. Now, why am I giving you these handwritten ones rather than these Delta Math ones? Because how many places are there to round numbers in these problems? A lot, correct? So if you're not really careful on how you're rounding, when you get to the end and it says round to the nearest tenth or whatever, could you have the basically right number, but have the wrong rounded number? Be pretty easy. I'm much more concerned right now that you get how to do this first without worrying about the rounding before we go to Delta Math and make sure you can round them well. That's a great question. It's whatever they say. Most of the time, they're going to have you round it. Yes. Because there's no way to do an exact answer. There's no square root version or whatever for laws of sines, laws of cosines. Does that make sense? So, again, we're stepping you forward here. Cool. And so, by the way, when are these going to be due? Monday. So you have your homework basically for the entire week, all the way through next week or into next week. Okay? Questiones? I'd recommend getting